Hi everyone, and welcome back to the second part of the series on DLL injection via app init DLLs. We've seen initially that we can use a special register key to specify a library to be loaded automatically by almost all the Windows programs. We've also seen how to inject libraries into 32 and 64-bit processes. In this part, we'll take this further and learn to perform an actual useful trick like function hooking. Let's see. We have some code already from the previous episode and we'll start building from this. Check that out for a refresher. For function hooking, we rely on a very useful third-party library. The library is called NtHookEngine, and I'll add the link below in case you can't find it. It's written and well documented by the author of CFF Explorer 2, and it works on both 64 and 32-bit Windows versions. Please do check this library out because it's open source and it has good source code examples on how to use it. That's where I took the code from and adapted it for this episode. Okay, let's look at the code and understand how it works. I'll link these two in the notes. This part stays the same. We show a message box when the DLL is attached to a process, then call a function named hook. The hook function loads the library NtHookEngine, which I have over here. From this library, it loads three functions: hook, unhook, and getOriginal function. You can infer what these functions do based on their name. Hook will hook a specific function from a DLL, and hook will restore the original. GetOriginal function is very useful if we need to call the original one after being hooked to keep the functionality of the application. The example I've adapted from the author's website hooks the library function called messageBoxTimeoutW. We will see in a minute why this specific function was chosen. The outcome will be that we'll be able to intercept or hook the messageBox function itself, which calls the messageBoxTimeoutW. This is just a twist of the library, explained also by the author. Let's continue. Let's slowly go through the code and understand how it works. First, we load the external hooking functions. We hook the messageBox timeout, then display a message box. Remember, this uses the hooked function. Then, we unhook it and print another message box to make sure that the function was restored correctly. To hijack the messageBox function, we will define another function here. It has to have the same signature as the original messageBox API. There's a small difference in the hooked version, which will call the original message box, but with another title. This is to show that we've been able to hijack it successfully. Let's compile and see. Okay, we have first an error. We cannot open the window DLL file. Let's delete it. That's because it's in use. Let's see a quick trick with Process Explorer search function. It can tell us if and which application is currently using the library. In this case, it seems that it might have been terminated, so let's try to delete the DLL again. We can see that it's used by Brave Updater. The problem is that Process Explorer was not started with administrative privileges. Let's fix this. If we redo the search for the DLL, we should now see Brave Updater. We can also terminate the process from here. Keep this trick in mind. It will be handy. Delete the library and recompile the new code. Let's just start any test application. Let's say the CL compiler. Here's the first message box, DLL was attached. The second message box was the hooked title as we defined it in the code. And the third message is using the restored version of the function, which has the original title. Great! We've managed to hooking the message box function. What's next? But why did we hook the message box timeout function instead of simply the message box? To understand this, let's check user32DLL Windows library, which contains the function. It is located in Windows System32 folder. We're specifying another location for IDA database because it can't write to the system folder. Do we want to look for the PDB file? We don't at this point. We'll cover debugging symbols in another video. Let's look at the exported functions and locate the message box API. Remember, in our code, we wanted to hook message box W for wide strings. The function is very simple, only a handful of blocks and a call towards the end. The structure of message box A is exactly the same. Notice this jump close to the beginning of the message box function. The problem is the hooking engine cannot replace this jump, because this is a relative jump. The workaround was to hook the function message box timeout instead. Although not documented on MSDN, if we analyze it, we'll notice that it receives exactly the same parameters as message box function, so we're not missing anything if we hook this instead. In message box W, we see exactly the same situation. If you want to learn more about how the hooking engine works, please do check the documentation and practice with other scenarios. Alright, let's move on and create a simple application. The program will generate some random numbers, very similar to the one I've used in another video on a similar technique for macOS. I will link it in the notes. Compile it and ignore the messages from the current hooking in place. Then run it to output some random numbers. You probably noticed we didn't see any message box from the current library hooking, which we've confirmed that it is in place when we compile the random number generator. Although we are expecting at least some of these message boxes to pop up, we didn't get any of them. Strange. The code looks correct. It seems that our library didn't get injected at all. We have to figure out what's happening, and we'll do this in the next episode. Let's go over what we've seen in this second part. Broadly, we introduced the very useful library NtHookEngine and went over some scenarios and caveats. In the next episode, we'll continue to work on our random number generator hooking. We'll fix the current issue we ran into and also discover more interesting pieces of this puzzle, which is DLL injection. Thank you very much for watching and looking forward to see you in the next part.